In example number 3, we're going to rationalize denominators that have more roots, and they're going to have fractions as well. So really this is just going to be using what we learned from the previous sections, now all combining with this whole notion of rationalizing. So like I said, it's all going to be building together here. So let's go to town on this. All right. First of all, let's just go ahead and we can rewrite this as negative radical 8 over radical 45. Yeah? Right? So I can just rewrite it as 2 separate radicals instead of it like only having one right there. Okay? All right. So I have negative radical 8 over radical 45. Let's simplify both the numerator and the denominator. Okay? So first of all, I know that the numerator can become radical 4 times radical 2, right? 4 times 2 is 8. And the denominator become radical 9 times radical 5, right? All right, now I'm going to move down here. So radical 4 is just 2, right? So that's negative 2 radical 2. Okay, so I just simplified radical 4, which is a negative 2 then, because the negative sign, negative and then 2. All over, square root of 9 is just 3 and then radical 5. Okay? Now we can't leave the answer like this because we're supposed to rationalize, right? We can't simplify, or this needs to be even more simplified by rewriting this so it does not have a radical in the denominator. All right? So now let's multiply top and bottom by a radical 5. Okay, again, all I'm doing right now is I'm rationalizing. Our final answer should never have a radical 5 in the denominator. Okay? So let's see. I multiplied the radical 5 and the radical 2. So I get negative 2 radical 10, right? 2 times 5 is 10. And in the denominator, I get 3 and then times 5. Okay? So my final answer is negative 2 radical 10 all over 3 times 5 is 15. Okay, before we go on to part B, let me just make a note of something real quick. If you're wondering, oh, well, why can't we divide 10 and 15? They both have a factor of 5. Divide that by 5 and then divide this by 5. Okay, the reason why we can't do that is because the 10 has a radical sign. And see, the square root of 10 is a decimal, like 3.1 or something like that, right? So it's going to be, it's just after the square root of 9, so it's 3 point something. And this right here is 15. So really this number is not 10. This number is square root of 10, which happens to be 3.1 and 3.2, and this number is 15. So as you can see, 5 really doesn't go into both of these. And my point really is this, is that you could only simplify or cross-cancel radicals is if you have the same radical on top and bottom, okay? So just a little note right there. All right, part B, let's go. So first of all, I'm going to go ahead and just rewrite these as all separate radicals, and then I'm going to break down each radical. So I can rewrite this as the square root of 200 times the square root of k to the power 6 all over the square root of y to the power of 7. Okay, so this is equivalent to the left side. So I'm just showing that. I'm just going to break this down into separate radicals, and I'm just going to take one radical at a time, simplify that bad boy, and then we'll go from there. All right, so let's first deal with the radical 200. Okay, so I can rewrite the radical 200 as radical 100 times radical 2. 100 times 2 is 200, and 100 is the biggest square root that goes into 200. Okay. Now let's remember here the index is 2. So 2 goes into 6 3 times. So really I can just rewrite that as k to the power of 3. So that's a nice one. When it's an even number, you just got to divide that right there. Okay. Not so nicely for the denominator here. This is the 2 right here. So 2 goes into 7 3 times. So that means I have to rewrite this as 2, or the square root of y to the power of 6, right? Because 2 goes into 7 3 times. So here's my 3 times right here. 2 goes into 6 3 times, times the square root of y. That's the square root right there. Okay, so y to the 6 times y is y back to the power of 7. Okay, so let's clean this up now. The square root of 100 is 10. Square root of 2 is just square root of 2. And then we have k to the power of 3. So 10 k to the power of 3 times radical 2. All right, nice. Now, I can simplify the square root of y to the power of 6 as just y to the power of 3, because 2 goes into 6 3 times. So that's y to the power of 3. And then I just write that as the square root of y. Okay. Now, do we leave it like that though? Are we done with this problem? No. We're not, right? Because we have a radical in the denominator. So we have to rationalize this. And that means I have to multiply top and bottom by radical y. Okay, see what I'm saying right now? Because anytime that there is a radical in the denominator, I am the denominator. Okay, you need to multiply by that radical top and bottom to rationalize it. Okay, so now if I simplify this, the numerator is 10 k to the 3. Now since they both have the same index, I could just rewrite that as square root of 2y. Okay, and then this right here just becomes y to the power of 4. And I kind of skipped a step here because watch this. Y to the power of 3 times radical y times radical y. Isn't this right here just radical y squared, right? So this is just y squared. Square root of y squared. Well, square root of y squared is just y. So y times y to the power of 3 is y to the power of 4. So that's where I got that from. And that's it right there. It'll be this guy right there. So a little bit more tricky now. I mean, we're using all kinds of rules that we've learned. It's all like piling up on here, you know? Okay, let's see if we can tackle part C now. Okay, let's see this hairy guy. First of all, I'm going to do the same thing like I did for part B and break this up into 3 separate radicals. So I'm going to break this down into square root of 50 and square root of m to the power of 4 and then square root of p to the power of 5. Okay, let's look at the numerator here. Let's break down radical 50, and I can rewrite that as square root of 25 times square root of 2. Okay, so that's what square root of 50 becomes. And this is nice. The square root of m to the power of 4 is just m squared, because the 2, which is right here, goes into 4 2 times. All right? And this one is odd. So and there's a 2 right here. So 2 goes into 5 2 times. So that means I'm going to do the square root of p to the power of 4 times square root of p. Okay? So let's simplify this now. Square root of 25 is just 5. Square root of 2, we leave it like that, and m to the power of 2. So 5m to the power of 2 times square root of 2. And the square root of p to the power of 4 is just p squared, because I divide the 2 goes into 4 2 times. And I have my radical p. And I guess we're done with this problem then. No, we're not done, right? We have a radical in the denominator. So we need to rationalize. So top and bottom by radical p. And then we finally get our answer as 5m squared square root of 2p all over p squared times p, which is just going to be t to the, or p to the power 3 on the bottom. And I'll go ahead and write another line now. Pretty crazy and crunchy, if you ask me.